Hello, and welcome to the series of digital design workflows orientated around the facilities available to you at KSAP. In this introductory session, I will walk you through our 3D digital workshop, exploring all the tech available to you to expand and adopt, if you wish, throughout your design projects for this academic year. Let's get to it. Our digital facilities are focused around two main aspects of technology: 3D capture and computer-aided manufacturing. However, the key part of it all that will enable you to expand on the creative application of the technology's basic functions are the software tools. Let's start with the data capture options. When talking about 3D scanning, the information that you would like to work with is more important than the object that you are actually capturing. Thus, the emphasis on data. There are fundamentally two forms of data that you need to be aware of: point cloud and mesh forms. Though it is possible to convert the one to the other, understanding the end goal of how you would like to use data and for what purpose will help you choose the right technology to achieve said purpose.
These tools may look alien and complex to grasp, but one of the greatest elements of advancement in technology is that now you can capture both forms of data with your smartphones. And whilst the quality of the data may not be of such a high standard, it is perfect to enable you to explore your creative intentions through a digital workflow. Let me show you. I'm just going to elaborate on the options that you can do yourself with your smartphones. And once you have experimented with these options, I'll be more than happy to assist you with the use of a higher caliber technology if applicable. So, to achieve a mesh form for an artifact capture, let's say, the methodology is called photogrammetry. It is a simple process of taking a number of photographs around the artifact to collate all angles visible through the lens, both horizontally and vertically. After which, you can upload all the images into the Autodesk software Recap Photo, which will combine all your images on the cloud server and email you back with the final output created as a 3D mesh model. However, it is important to note that the mesh forms will not be metrically accurate to the actual artifact captured, but you will have a 3D model with an associated texture map file to further explore your intentions using other manipulation software.
Now, when it comes to point cloud data, it has the capacity to capture metrically accurate data, and thus is heavily used in industry as a surveying tool. You can achieve the same results with your smartphones and a web-based service. The online service is called Digimap, which not only provides you with LiDAR captures, but a variety of site surveying data. And I urge you to explore the YouTube videos available on our Kent School of Architecture and Planning Tech channel to understand how to register and use the available information freely. Now, the smartphone option is an app called 3Dim Capture, which will be available to download from October 2020 onwards for a low cost. The app will enable you to engage more with the context of your projects, as you will be able to retrieve detailed survey information from a basic video capture done through your phone. Once you have uploaded your recordings via the app, you'll be able to view the entire point cloud data captured either on a web browser or download the file to further manipulate using Autodesk Recap Pro. Well, this covers the main principle of 3D capture, but I will elaborate on your design workflow options in the upcoming episodes of this series. Now, let's move on to computer-aided manufacturing. The digital fabrication technology runs alongside the analog workshop managed by Kevin and Colin. The fundamental principles of fabrication, both analog and digital, are focused around fabrication techniques, which are dependent on the material output, the geometric complexity, and most of all, scale. These three factors will identify the technique best suited to communicate your design intentions, whether it be additive manufacturing or layering, subtractive machining or cutting, casting or molding, weaving, assembling, folding, and even forming. And the most creative applications have always consisted of a composition of techniques. The applied techniques will bring your intentions to reality. As we all know, it is easy to get lost in a computer screen when orbiting around a digital model that ignores all laws of physics. As a workshop team, we aim to achieve the most feasible options for you, and all we ask from you is that you allocate enough time to complete said process. Once your intentions are pragmatized through your choice of technique, the conversion of digital models to the physical requires you to achieve parameters that allow for the computer-aided machining. These parameters are based on the three factors mentioned earlier, and each machine we facilitate has its own limitation in regards to your options for digital fabrication. This information is all available on your Moodle page under module DP7100 for workshop details. Alright, that's all for this episode. For any advice or further details, please do not hesitate to contact me. You can find my details on the Kent School of Architecture and Planning website under People and Technical. Take care.